Good morning to all. Welcome to the fifth session of Mechatronics first chapter. Today we shall discuss about Hall effect sensor. Hall effect sensors can be used as position, displacement and proximity sensor. This can also be used for measurement of speed. If the object being sensed is fitted with a small permanent magnet. When a beam of charged particles passes through a magnetic field, forces, that is, magnetic forces acts on the particles and the beam is deflected from its straight line path. That is, current flowing in a conductor can be deflected by a magnetic field. This effect is known as Hall effect. Consider the electrons moving in a conductive plate with a magnetic field applied at right angles to the surface of a plate. During this process, the electrons deflected on one side becomes negatively charged while the opposite side becomes positively charged. This charge separation produces an electric field in the material. The charge separation continues until the forces on charged particles from the electric field just balance the forces produced by the magnetic field. This results in production of potential difference called Hall voltage. This Hall voltage is the measure of the magnetic flux density. The next sensor is tachogenerator. A tachogenerator is a device which is used for measurement of speed of a shaft and converting it into a voltage so that it can be measured. A DC tachogenerator is a speed transducer which develops DC voltage proportional to speed of the motor connected to it. It consists of a coil called as rotor which rotates with the rotating shaft. When the coil rotates, the magnetic field is produced by a stationary permanent magnet or electromagnet and produces an alternating EMF, that is voltage. The amplitude or frequency of this alternating EMF can be used to measure the angular velocity of the rotor. Next important sensor is light sensor. The light sensor is a device which detects the presence or absence of a light. When a light falls on these sensors, the light signals, converting it into electrical signals. It is also called photoelectric transducers. Example, photodiodes, phototransistors, photoresistors. First one is photodiodes. These are semiconductor junction diodes connected to circuits in reverse bias condition, giving very high resistance to the flow of current. When light falls on the junction of the diode, the resistance drops and current in the circuit is increases. They are very fast response to light. The figure shows the photodiode. Phototransistors. These are light sensitive collector base PN junction. When there is no incident light, there is a very small collector to emitter current. When there is an incident light, a base current is produced which is proportional to the light intensity and produces a collector current which is the measure of light intensity. Photoresistors. Photoresistors have a resistance depends on the light intensity falling on it. The resistance decreases linearly with the increase in light intensity. For particular value of light intensity, corresponding decrease in resistance is the measure of light intensity. The next important sensor is optical encoder. This is the most popular position measuring sensor used for the measurement of rotational movement or angular position. They are of two types. One is incremental encoder and the other one is absolute encoder. These encoders consist of a disk divided into number of sectors as shown in the figure. They are alternatively transparent and opaque. A light source is positioned on one side of disk and a light sensor is placed on the other side of the disk. As the disk rotates, light fall on the sensor. The sensor detects light and the output from this sensor switches alternatively on and off, which is approximately sinusoidal wave. The amplifier amplifies the signals and converts sinusoidal wave into square wave. The angular position of the disk is determined by calculating the number of square wave pulses. Thank you.